This next example is going to help us think about conditional probability and the rules that kind of go along with it. And so it gives us 4 different people, and it tells us that out of those 4 people, one of them is going to be chosen to be a chairperson, and another one is going to be chosen to be a secretary. And what they do is they write their names on a piece of paper, and they just draw 2 names at random. And so since everybody is putting their name in that bucket only once, their name cannot be drawn 2 times. So if Dina is chosen as the chairperson, she can't also be chosen as the secretary. And so to think about part A, the possible outcomes, I'm going to first consider the cases, okay, when is Dina chairperson? And so if Dina is chairperson, then the other 3 can be her secretary, right? So either Glenn is the secretary, Mateo is the secretary, or Cheyenne is the secretary. And so that covers all of the cases when Dina is the chairperson. And then I can do, okay, what happens if Glenn is the chairperson? If Glenn is the chairperson, then Dina can be the secretary, or Mateo can do it, or it can be Cheyenne. And then I'm going to move on to Mateo. If Mateo is chairperson, then the other 3 can be the secretaries, and the same thing for Cheyenne. And so CG and CM. Looking at this then, we can see that there are 12 total outcomes, which is going to help us answer this next part. And so the next part says, what is the probability that Cheyenne is secretary? And so to consider that, we have to find all of the cases, regardless of who is chairperson, where is Cheyenne the secretary? And so that's basically when the C shows up in the second spot, right? So it can happen 1, 2, or 3 times. And so here, the way you can think about this, and so I'll write it in probability notation, so probability that Cheyenne is secretary, this is going to equal the number of times her name appears second, and then I'm going to divide it by the total number of outcomes. And so when I do this, I get 3 out of 12, which is 0.25. Part C is asking now, okay, suppose that Glenn is the chairperson. What's the probability that Mateo is his secretary? And so this is the example for conditional probability. And so if you think about this, if you think about this, we're finding the probability that Mateo is the secretary on the condition that Glenn is the chairperson. And so if I go back up here and I look at this probability notation, it's read as the probability of A given that B has already occurred. And so in this case, A would be Mateo being the secretary given that Glenn is chairperson. And so let's write that out in probability notation. So probability that Mateo is secretary given that Glenn is chairperson. And so to think about this, what I'm going to do is I'm going to say, okay, how many times is Glenn the chairperson, right? Because this is all based on the condition that Glenn is the chairperson. And so I'm just going to look at these 3 outcomes. And so here, the total number of outcomes that I could possibly have for this example is no longer 12, it's now 3. Because there's only 3 possible outcomes where Glenn is the chairperson, and this is all conditional on the fact that he is the chairperson. And so if I were to write this out in words, and so I'll write out the numerator in a second, this would be the total number of outcomes when Glenn is the chairperson, which is equal to 3. And so I'll kind of squeeze that in right there. And then now to figure out the numerator, that's going to be, okay, out of those 3 times, how many times does Mateo's name show up as his secretary? And the answer is 1, right? It's this one right here. If Glenn is chairperson, Mateo can only be his secretary once, right? And so this numerator would be number of times Mateo is Glenn's secretary. And that only happens once, so my answer here is 1 out of 3, or 0.33. Technically it would keep repeating, right? But that's okay, I'll chop it off right there. The biggest thing to take away from this example is the fact that our denominator went from 12 to 3 because of that condition that we put on our probability, right? So that's what I talk about next. And so make sure you review this next portion, because it says that the denominator is now just the number of times that B can happen, right? And so that's why up here we had 3. This example is asking us to refer back to that example A that we were talking about a few minutes ago. And so I went ahead and I copied the table over here so that it's just easier so I'm not scrolling. And so this is asking us to find the probability that somebody is in favor based on the condition that they are male, right? And so, or here, really it should look like this. So the probability that somebody is in favor given that they are male. So if I look back up here at this formula, this is going to equal the number of males that are in favor divided by the number of males. And so notice here that my denominator is all based on the second thing that shows up in my probability notation, right? And so the number of males that are in favor, we had found that earlier when we were talking about and probabilities, and so I'm going to do this again. I'm going to look at the intersection of these two categories. And so I care about that 15 again. That's how many males are in favor. And rather than dividing it by 100 this time, I'm going to divide it by the total number of males. Not the total number of people, because it's on the condition that the person I'm selecting is already male. And so imagine that you have a bag of people, and out of those 100 people, you have 60 males and 40 females. And now imagine that I took the 40 females out, and so the total in my bag of people, which are only consisting of males now, the total in my bag is now 60 people. And so that's why my denominator is now 60. So when we do the calculation for that one, we get 0.25. And so now if I move on to part B of this example, it's asking us to find the probability that somebody is female given that they are in favor. And so in my bag of people, in my bag of 100 employees, I'm going to remove all of the people that are against this. And so my new total is now going to be the number of people that were in favor, right? And so that's going to be this 19 right here. And so if I write this out in words, this is going to be the number of females that are in favor divided by the number of in favor. And so I already know my denominator is 19. To find the numerator here, I'm going to look at the intersection of in favor and female. And so here I care about this 4, and so I'm getting 4 divided by 19, which is equal to 0.21, and then you can round that up to 1. And so there's the probabilities for this example.